All right, today we're going to be doing 2.5. And we're going to be looking at finding the zeros of a function. And what we're going to do is we're going to use the fundamental theorem to determine the number of zeros. We're going to use the rational zero test. We're going to find the zeros. We're going to use the zeros to write polynomial function. And we're going to look at Descartes' rule of signs. So fundamental theorem of algebra says that if f of x is a polynomial of degree n, meaning degree 5, for example, then n has precisely 5 linear factors. Okay? Where c1, c2, and c through n are complex numbers, meaning they could be real numbers or they could be imaginary. Rational zero says that if I have a polynomial with integer coefficients, every rational zero is in the form p over q, where p is the factor of the constant at the end, q is are all factors of your leading coefficient. So let p be a polynomial function that has real coefficients. If a plus b, where b is not 0, is a zero of the function, then the conjugate a minus b. So what we're saying is, in this one, is that if we have a complex zero, like 3 minus 3i, then its conjugate is also a zero, whether they tell you that or not. So for this one, it says find all zeros. So we set this equal to 0. And how do I find all zeros? How do I solve that? And set them all equal to what? 0. So x minus 3 equals 0. 2x plus 1 equals 0. X plus 3i equals 0. X minus 3i equals 0. So then our zeros are 3, negative 1/2, negative 3i, and 3i. Side note, how many times does this graph cross the x-axis? 4? Who agrees with 4? Who doesn't agree with 4? Where is 3i and negative 3i on the x-axis? It's not. So it only crosses 2 times. Okay, these are imaginary. We can still have zeros there. They're just imaginary.
So even though it has 4x, it still be
All right. List all possible zeros for f of x equals negative 2x to the 4th plus 13x cubed minus 21x squared plus 2x plus 8. Use your graphing utility to narrow the list and determine all the real zeros. So remember, p over q is the form that we're going to have. P is what? P are the factors of which one? Of the constant at the end, 8. Q are all factors of what? The 2.
So is that P over Q?
It's P over Q. And it's going to be plus or minus. So we really don't need to worry about that negative sign there. So what are all the factors of 8? 1, 2, 4, 8. What are the factors of 2? 1 and 2. So what we do is we take all these, divide them by 1. It's 1, 2, 4, 8. Then we take all these up here and divide them by 2. So plus or minus 1 over 2. Well, what's 2 divided by 2? 1. It's already listed. 4 divided by 2? 2, already listed. 8 divided by 2? 4, already listed. I don't need to have plus or minus there again. I have it out here. Then it says use your graphing utility, use your graphing calculator to find the exact zeros. So, do you have your graphing calculators? Spencer, needs a graphing calculator. Lisa and Riley look nothing alike. Spencer and Mason do.
A printer.
All right. So y equals, and we're going to put our function in. Negative 2x to the 4th plus 13x to the 3rd minus 21x squared plus 2x plus 8. And what's the most of the most amount of zeros we're going to have? 4. I know that my zeros are between negative 8 and positive 8. So what are our answers going to be? Do I need to go find zeros? Well, I know this one over here is what? Let's see. So this one right here is what? That's negative a half. What's this one right here? 1. What's this one? 2. 3 and 4. If I did the table, does that work? Well, there's 1, 2, and 4. I could go table set ask, and I could type in 1/2, negative half, thank you, and get 0. So what's nice about this is now we can not only narrow down where our zeros are, but we can actually now graph it, and we won't have to find the zeros and put that between here and here. We now know where our zeros are going to be. Question there?
you get the factor of 2 from 2x or the negative 2x?
And then there's the plus or minus. So
Say which one?
For the factor of 2.
This
That
2 up here?
Like, at the very beginning, you were a factor of 8 over a factor of 2.
Yeah, 8 is the, if you go back to the rule, P over Q, P is the factor of the constant. All factors are constant. Q are the factors of the leading coefficient. Leading coefficient's negative 2, I don't need to worry about the sign. Okay. Use your graphing utility to approximate the zeros for this one. All right, so let's go y equals. We've got x to the 4th minus 3x squared plus 2. We know that it's just going to be factors of 2, so plus or minus 2. Oh, and 1.
Okay.
So I'm gonna do my windows, and I'm gonna do between negative 2 and let's go 3. Let's hit graph. So there, it brings it up. So how many zeros are there?
Would it be 4?
Could be 4, and if we want to even look more, let's make our negative 1 and 1. There, looky there. So we know it's 1 and negative 1, right? But what are these other ones? Now we're going to calculate 0. Go the wrong way. There's left bound. There's right bound. So we get a 0 of 1.414. Left bound, right bound, and negative 1.414. How come these two didn't show up here? Because P over Q is for rational zeros. Okay? Rational number means I can write them as fractions. That's not necessarily going to give us all our zeros. You can tell by looking, it's 1.414214. So those are not rationals. So now it says determine the exact zeros. Okay, these aren't exact. How can I figure out how to factor this some more? We can do synthetic division. We can take this 1. So there's a 4th, there's no 3, there's a 2, there's no x, and there's a 2. If this is a 0, this is going to divide evenly. I I gotta get a 0 here. So drop the 1. Bring it up. From our zeros, we know x minus 1 and x plus 1 are factors. If 1 divides evenly into this, so that leaves us with, this is what, x cubed plus x squared minus 2x minus 2. We know now that negative 1 should factor into this, right? So let's find out. And usually what I do is I just go like this. I put a backwards L here. I don't rewrite them. I don't worry about this anymore. Drop the 1 down. Negative 1, 0. 0, negative 2, 2, 0. So what is this? This is x squared minus 2, right? So that's my next factor. We already know our real zeros are 1 and negative 1. How do I solve x squared minus 2?
Set it equal to 0.
Set it equal to 0. Add 2. Square root.
Plus or minus.
So there's our exact values. Questions on that one? So synthetic division is going to come into play again. We're using these to maybe come up with and finding where they are. Now I'm going to tell you, find a polynomial function with real coefficients that have the given zeros. So now you're taking something like this. I'm giving you this. You need to work your way back to the original function. So first thing is, if I know zeros, I can write factors. So work our way backwards. So if 1 is a 0, what's the factor for 1? X minus 1. So then that means this is going to be x minus 5i and x plus 5i. When I ask you to write a function, make sure you write f of x equals. Many of you will not do that on a test or a quiz, and you'll lose points because if you don't write f of x equals, you're not writing a function, you're writing an algebraic expression. Yes?
Are we allowed to write y?
Y equals. That's fine. Now we're going to multiply it out. I'm going to multiply these first, because x times x, x squared. What happens to the middle terms? Positive 5i, positive 5ix, negative 5ix, they cancel. And then this is minus 25i squared.
Grab wanted me to come down and ask what we're doing tomorrow in calculus, because he wants me to leave at 10:45 to go to the middle school and help him with the thing. That's what he says.
Questions there? So minus 25i squared is what?
Plus 25.
Plus 25. Now do you see where the I came from when you would solve that? You subtract 25, square root it, you get the square root of the negative. Now multiply the rest of this out. Distribute the x cubed plus 25x minus x squared minus 25. Please write in standard form. Highest exponent all the way down to
It's x cubed, right?
yes, thank you. All right, remember one of our rules said that if 5i is a 0, then its conjugate has to be. So sometimes they might list the conjugate, sometimes they might, but they expect you to know that. And I think that happens in your homework. If 6 is a 0, negative 5 plus 2i is a 0, then negative 5 minus 2i has to be a 0 also. I'm going to write this a little different because remember when we solved, remember we set those factors equal to 0 and we got x equals? Now let's take these back. So that would be x minus 6 is a factor. What factor did I get here? X, what? Plus 5 minus 2i. And then this will be x plus 5 plus 2i. And f of x equals. We have to multiply it out. Where are we going to start with our multiplication? Multiply the ones with the complex numbers first. So distributed x through x squared plus 5x plus 2xi as I do this, I'm going to line up my like terms. So then distribute the 5 through 5 times x, 5x, 5 times 5, 25, 5 times 2i, 10i. Notice I don't have anything to line them up with, so I'm just lining them up out here. Now I need to distribute the negative 2i, negative 2xi, negative 10i, and this is what? negative 4i squared, that's going to become a constant. Add straight down. X squared, 10x, that cancels, and we get plus 29. Now what? Are you done? No, what are we going to do next?
Distribute the x.
Distribute the x through. So x cubed plus 10x squared plus 29x, and then distribute the negative 6. Add straight down. Do you guys understand that if I ask you to solve this quadratic, you would have to use the quadratic formula to solve it? And that when you use the quadratic formula, your answers would be negative 5 plus 2y and negative 5 minus 2y?
Yes.
You see that? X squared plus 10x plus 29. It's negative b plus or minus b squared minus 4 times a times c all over 2a. So 29 times 4, 116. Is that right? So we get a negative 10 plus or minus the square root of negative 16 all over 2. So negative 10 plus or minus 4i divided by 2, and everything gets divided by 2, so there's your negative 5 plus or minus the 2i. Okay? Find all real zeros. P over Q. P is 2, Q is 2. So it's plus or minus 1 and 2 on top, 1 and 2 on bottom.
Where did you get the 2 and 2? What were you looking at?
Okay, back over here to our rule. Rational zero says that P is a factor of the constant term. Q is a factor of the leading coefficient. Okay, so for this one, our P is this right here. What?
What if there is no change?
Then we would be able to factor out a constant. Then we would get something inside there where there would be a P. Okay? And then Q is that leading coefficient here. So our possible zeros are plus or minus 1 and 2 and 1/2. So now we're going to do synthetic. It doesn't say to use a graphing utility, so we're not going to. We're going to do it longhand.
Yeah.
So we need to do synthetic division, and we need to try all these. So let's start with 1. Across the top is going to be 2, 5, 4, 5, and 2. 2, 2, 7, 7, 11, 11, 16, 16, and 18. So is 1 a possible 0? Now, let me ask you something. Let's look at something called number sense. If I would go and put up, do you think any of these positives are going to work? Because everything's just going to keep getting bigger and bigger. So I'm not even going to bother trying with the positive 2. 1/2 is still, these numbers are still going to get bigger because we're going to take all this is positive up here. And so all these are going to be positive, so these are just going to keep getting bigger. So this is never going to go to 0. So let's start with, let's forget all the positives. Now let's go to the negatives. So we've got our 2, 5, 4, 5, 2. Drop the 2 down. There's negative 2, that's 3. Negative 3, that's 1. Negative 1, that's 4. Doesn't work. I don't need to do that math. I know it's not going to work. So now we're going to try negative 2. So 2, 5, 4, 5, 2. You understand I can't go use these because it's not a factor. I have to go back to my original. So negative 4, 1, negative 2, 2, negative 4, 1, negative 2, 0. So I know negative 2 is one of my zeros. So I have one more to check. Which one is that? And what am I going to divide a half into? The original? No, this other factor down here. So I'm going to use this one and take a negative a half. 2, 1, 2, 1. See what happens. There's a negative 1, 0, 0, 2, negative 1, 0. So negative a half is another 0. If it started with x squared, this was x cubed. What's this one? So this is x squared plus 2 is my last factor. So x squared equals negative 2. So x equals plus or minus square root of negative 2, which is the square root of 2i. I put the I in front. Up, what did I do wrong? Where did I mess up? This is 2x squared. Just going to be plus or minus I. guys remember Descartes' rule of sign changes? Never heard of it.
Is there a negative one under there?
What's that?
Why is there a negative one under the square root?
Because when I divide by 2, I get -1. So divide by 2, divide by 2. We get x squared equals -1. And then I wrote it as I up here. All right, last one. Descartes' rule of signs tells us that the number of positive real zeros, so now we're going to be able to rule these down and figure out how many possible real positive numbers we have, how many possible real negative numbers. The number of positive real zeros is equal to the number of sign changes or less than that by an even integer. So first of all, we need to look at the sign changes. The negative zeros are how many sign changes we have for the negative, or f of negative x. So we're going to have to do a little bit more work. And then it says even by a negative integer, if we get 12, then it's 10, 8. We just go down by 2. If we happen to get 7 sign changes, then it goes down by 2, 5, 3, or 1. Okay? It goes down. That's a possible. We can't rule it down to exactly how many. We can come up with an estimate. So for the positive, we look at the sign changes. Well, do I have a sign change here? No, this is positive, this is positive. Do I have a sign change here? Positive, positive, no. Sign change here? No. So there are no real positive zeros. Questions on the positive for A. B is where the work comes in. First, we need to find f of negative x. That means I have to plug in negative x. Where will the signs change here? Well, that's going to be 3 times negative x cubed plus 2 times negative x squared plus negative x plus 3. A negative raised to the third power is what? Negative, so this would be a -3. Negative squared, positive, so this sign won't change. What about this one? Be negative. Now look at the sign changes. Do I have a sign change here? Do I have a sign change here? Negative to positive, positive to negative. Do I have a sign change here? Yes. So how many yeses do I have? 3. So I have 3 possible negatives, or 1. So what this does is if I was asked you to find it, P over Q, well, our P and Q's are 3. So it's plus or minus 1, plus or minus 3, plus or minus 1/3. So what's that tell us? Do I even need to bother checking any of the positives? No. I'll check, I only need to check the zeros, the negatives. So I don't have to waste my time doing synthetic division like I did over here. This one here, remember, we talked about this was 1. These are all positive. There are no sign changes, which means there's no positive zeros. And we kind of figured that out once we did one of them. We would have had Descartes' rule. We wouldn't have had to waste our time doing that one. Okay? Let's look at B. Positive. How many sign changes from here to here? A sign change from the first term to the second term? What about from here to here? So we have 2 sign changes.
How does it change?
Well, this one's positive, and this one's negative. So we have 2 or 0 positive real zeros.
If that was
How do you know?
4, it'd be 4 or 2.
What?
How do you know the or? Like on the last one, how did you know?
It goes down by an even number. So I just subtract 2. Then for the negative, before I can determine the sign changes, I have to plug in a negative x for all the x values. So this is at 2x to the 4th plus 3x plus 2. How many sign changes here? No. Nope. So there are no sign change. So there are no negative real zeros. All this looks at just real zeros. It doesn't look at complex. Questions there?